Hi everybody, I'm Prateek. I'm from Tata Communications and I'm here to share our project on Cloud Inspector. The goal of this project is to find the root of failure in OpenStack logs. Say you're spinning a VM and you are thrown away with an error message, no valid host was found. This message at least tells us that there was no host available to spin this VM, right? But what do you rectify in your environment to make it work? So you will go dig out in your logs and you find out, okay, there's an error which is disk filter return 0 host. This at least tells us there was no disk capacity across any of the hosts to spin this VM, right? So this is what we call as root of failure, a condition which leads to an error message which can be rectified for things to proceed further, right? So what are the current approaches today we have to really go and dig out this root of the failure? So the first approach is when you look at the message on an UI or a CLI saying that it's a no valid host found or a block device mapping error, you figure out which component it belongs to, you go to that node specifically and try to trace back to see if there is a real condition that actually has caused you a failure just in case as disk filter return 0. In an HA environment, you will have multiple nodes to do these activities, so you will have to go to each node and try to figure out where the problem is. And if it is in a different component altogether from Nova to Cinder or a Neutron, you'll have to go and visit all those nodes again. And lastly, if nothing works out, you would have turned on your debug mode on all the nodes and in the services that you think about, and then you redo the action and you work out your problem. So to at least avoid the problem that you have of going to each and every node, you would have done a log aggregator setup where you'll have an ELK, Elasticsearch, Logstash, and Kibana kind of setup, where the logs from each of these nodes are pulled together in one area, and you would have looked at using an UI to find out whatever log entries you want, right? So let's look at the challenges that we have with these approaches that we use. First is it's difficult to find the API request flow from one component to another. What do we mean by this is whenever a Nova invokes a Cinder API call or a Neutron API call, how do you track these two things? Today we generally do it based on the timestamp alone that we have. Consider a production environment where you may have a lot of heat stack kind of things going on, or a lot of people using your environment. How would you do even the timestamp mapping there? So that's going to be a challenging task. And the next one is when you talk about aggregated logs from all the components of all the nodes, so the gap between the real situation, the real condition that you have and the error message can grow significantly because everything is happening at the same time. And if you have enabled the debug mode for doing this, there'll be a lot of things will be filled up between these two guys, which is going to worsen your situation to find the root of failure. The last one is restarting the services to enable and disable debug mode in a production environment is going to be a challenging task because you don't know which services you have to enable and then disable, right? So let's look at it. How do we do it at Tata? We use our Cloud Inspector framework, which allows us to inject two new fields that we have designed. The first one is unique API flow tracking identifier. This helps us to go to log aggregator setup and look at the Kibana UI kind of thing, wherein if we give this tracking ID, it helps me find out only the logs that have participated in the creation of a VM, not anything else. And then the next one is the dynamic logging level, which helps me enable the debugging, debug level log, dumping in the logs whenever this VM is being created, not otherwise. So if there are two parallel things that are going on, Neutron port create and VM provisioning, Neutron port create logs will not be at the debug level. It will be only the VM creation which will be at the log level, debug log level. And when you add this framework to your log aggregator setup, like I said, you can use this tracking ID and search out logs in your Kibana UI. The magic is pretty simple. It's very easy to find out the error. So I'm going to show you the demo, how we do it. So we're going to do a launch instance here. We're going to use a ELK setup at the backend. And these are the two new fields that we're talking about, debug and tracking ID there. I'm not going to touch it for the first instance. I'm going to let the system or the Cloud Inspector framework create a tracking ID for me. And I'm going to input an instance ID, select a flavor, and then do a boot from volume. So this boot from volume is going to create me a volume as well at the boot time. And so this is in error state right now. It has gone, and let's look at more details about this. The message says build of instance failed, failure prepping block device, right? So let's go to the action log. And this is the request ID that you were used to get earlier, but this has been appended with things here. This is the tracking ID that you have been appended with. So this is the Cloud Inspector has added it. Now we will use this tracking ID and go and put it into the Kibana. And yep, so this is the Kibana dashboard where we have entered it, and we're going to see the logs here. So these logs that we see are from all the components like Glance, Nova, Neutron, Cinder, and on the right side you see the messages are warning, error, info kind of thing. So these are the default behavior that you have in your production environment, right? And so we keep on going, and we see that Cinder volume, it says create failed over here. And when we scroll down a little bit more, we see a Cinder scheduler error here, which says me that it's a traceback that it is there, which is not beautified in this. So there is a if self.configuration1, there is an attribute here, error over here. Now this means that there is a problem at this line number, which probably is in lvm.py. So this is how you can probably get to the Cinder volume, Cinder scheduler error from the Kibana UI pretty simply. Right, so let's go and just take a look at this file and see why this error is. So basically it's me who added this just to create this error message, and that's about it for the first demo. Now let's go to the second demo where we are going to show you a no valid host found error. So this time I'm going to enable debug because I want to be sure that if there's any extra information I need, it is all present. And I can even input a new tracking ID that I want. And in this case, I have input as my personal tracking ID as a tracking ID. But you have to ensure that this tracking ID is unique across any time you have used it. Otherwise, you will get logs from 2 different VM creation or any other process that you might have done. Right, so this is the zoomed view of it. And let's select the network and move on. So it goes into error state. Let's look at the details of this VM. So there we see is no valid host was found. There was not enough host available. So let's try to find out the reason for it. And this is the action log. Again, we go and look at it. And this time we see this tracking ID that we had used. Last time it was a system generated hexa number. This time it's my personal tracking ID that I had provided there. And then you have one more tag, which is DLL. This is dynamic log level that we have input. And the level is debug because that's how we had configured it for now. And then it continues, and we are going to take this and put it into the Kibana. So you could do this without even the DLL debug tag. And now we should see some log levels in severity label as debug as well when we search the logs. So yeah, there you go. You have info, you have debug. That means that worked. And then we are going to just search for no valid host found for the quickness. And we do see there is a no valid host found error over here. If you go back at the logs, we do see there's a disk filter return 0 host. Fair enough. So this is an info kind of message. So now why did it return a disk filter return 0 host to you? There's a log entry just above this, which is from Nova Scheduler. It is in debug mode, if you can see this. And then it says it's on one of the compute host, which it picked up, and it says does not have enough usable disk. It only has this. So I know now what to really work on. So it gets that simple to really find out what you need to really rectify in the environment, right? So how we implemented it now. So today when you have to launch an instance, the request goes to the Nova API framework, and one of the workers pick it up. Now what the workers do is they look at the request, they look at the headers, and they look at the request body that you have, and they build a context within themselves. And they use that context to pass it along to the RPC calls that they make internally, but not to the API requests that they make to the other services that are like Glance, Cinder, and Neutron, right? So what we have done is we have injected these 2 new fields. One is dynamic log level, and the other one is your tracking ID. So these things get flown to again to the worker. Now the worker picks up these 2 things from the request, or it generates a new tracking ID if it has to, and then it puts it into the context that he has. He takes this context to the RPCs as it is being done by default. Now what we have enabled here is this context needs to get passed along with the APIs. So when he's making an API call, we look at the context if it has a tracking ID and the log level. If it is there, then we go pass along with the API as a new headers. Since each request is taken up by different workers, so it is an isolation that you have there. And all these guys do a logging, and logging looks at the context, whether there's a tracking ID. If there's a tracking ID, they dump it. If the dynamic log level is set in it, it logs, it lets the debug level log being dumped into it. And all these things go into your log aggregator and Kibana UI view. These are the changes in OpenStack that we have done. It's primarily on the Oslo and the Keystone and your logging area. There's no driver changes per se. Nothing at all. It all's the framework thing, and there's a code location which is here. You can refer to the code. And the advantages are pretty straightforward. It's easy to find out the logs and find out the root of failure that you have across the components. No configuration change and no service restart to enable the debug logs. So this is primarily for the production environment that you can have. And for the beginners, they can identify how these APIs get flown and what all happens in the environment when a VM is being spun. And advanced users can have an opportunity to find out if there's any way to improve it. The future work for this is we are looking to integrate this with our ticket management system, wherein whenever the VM creation fails, we will generate an ITSM ticket. And we use this ITSM ticket to redo this action with debug enabled mode and pass this as a tracking ID. So once the next time the VM creation continues with a failure, there will be a link sent into an ITSM ticket with the Kibana view as a link and the query parameter set to the tracking ID that we have. So all the ops guy has to do it is just to go and click on the Kibana UI, and he has all the logs that he wants. And he can just go ahead and debug. He doesn't have to redo any action, set any parameters, nothing at all. Thank you very much.